Welcome to the coding interview question, combination sum. You're given an array of distinct integers candidates and a target integer target. Return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. Note that the same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. This is the problem statement. If you are given array equals to 2, 3, 5 and the target equals to 8, now we have to generate combinations that add up to 8. We have 3 combinations for this array that add up to 8. 2 plus 2 plus 2 plus 2 equals to 8. 2 plus 3 equals to 8. 3 plus 5 equals to 8. These 3 combinations that add up to 8 we can generate from this array. From the problem statement, we see that we can select an element from this array an unlimited number of times. If we are given array equals to this array and target equals to 7, then we have to return these 2 combinations. 2 plus 3 equals to 7 and we have only one 7. So we have to return this list of combinations for this given input. How we can solve this type of problems? To solve this type of problems, we have to use backtracking algorithm. Explaining backtracking problems always is a big challenge. I will try my best to explain this problem. Now let's see how we can solve this problem. For sake of understanding, let's assume we're given this array and we're given target equals to 8. Now we have to find combinations from this array that add up to the target. Okay, first let's review our algorithm. First, we're going to declare a function bt for backtrack that takes 4 arguments, remaining array, current, start, and list. Remaining initially our target. We will subtract our current element from target. By subtracting, if we found remaining equals to 0 during subtracting, then we will add the path to our list array. And here we have array, this is the given array, then current is the current combinations, and start is 0 initially, and list, this list will hold our answer. Here start equals to 0 initially because we will start from the first element. If remain equals to 0, then we will add that path to our current list or array list or linked list, depending on the implementation. Then we will return. We will not proceed anymore. If we see remain is less than 0, that means we don't have a combinations that add up to 8. In this case, we will just return. We will stop executing that current recursive function call. Then we're going to run a loop for I equals to start, I less than length of the array, and I plus plus. Then we're going to add the first element to our current list. Then we're going to call this function recursively again by subtracting the current element from target and the rest argument remaining as it is. If we found a path where we get by subtracting current element remaining equals to 0 or remaining is less than 0, then we will remove the last element from our list. Okay, and we will keep doing this process until we're done. This is our function calls. The first argument is target, second argument is our array, then third argument is our current list, and this list will store our current combinations. Then this is 0, this is for index 0. Initially we are starting with this element 2. Then we have list. This list will hold our answer, or in other words, this list will hold the combinations that add up to 8. Now let's see how we can solve this problem and how this algorithm actually works. I already mentioned you that explaining backtracking problems always is a big challenge. Now let's see how this actually works. First we have this element 2. Okay, so let's subtract this 2 from our target. If we subtract, then we get 6. For 2 we have total 3 choices. We can choose 2, we can choose 3, we can choose 5. So we have here 3 choices. Now for this choice, let's subtract 2 from 6. Then we get 4. Also let's calculate for 3 and for 5. For 3, if we subtract 3 from 6, then we get 3. And here if we subtract 5 from 6, then we get 1. Then for 2, we have again 3 choices. We can have 2, we can have 3, we can have 5. Alright, now let's calculate the remain for 2, 3 and 5. For 2, 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 5 is minus 1. Now for 2 we have again 3 choices. We can have 2, we can have 3, or we can have 5. Okay, so let's calculate for 2 the remain. So 2 minus 2 is 0. We get remain equals to 0 by subtracting the current element. So we found a path that a combinations and that add up to 8. So let's add this to our list. Okay, so we have added this path 2 to our list because we found a combinations that add up to 8. Okay, for 3 let's calculate the remain. The remain is minus 1. So we'll just return from the current recursive function call. Then for 5, we see we have minus 3. That is negative number. So we'll return from the current recursive function call by using this return statement. Okay, we're done here. Now we're at here 3. For 3 we have 2 choices. We can have 3 or we can have 5. For 3, let's calculate the remain. So 1 minus 3 is minus 2. So minus 2 is a negative number. So this condition true here. We're going to just exit from the current recursive function call. Then for 5, so 1 minus 5 is minus 4. So it will return. So we'll return from that recursive function call by executing this return statement. Then we're at here 5. We see at 5 we have minus 1. So we'll also exit the current recursive function call. Then we're at here. Here we have 2 choices, 3 and 5. Now let's calculate the remain for 3 and 5. So 3 minus 3 is 0. We found remain equals to 0. That means we found a combinations that add up to 8. So let's add this path because this path is a combination. So 2, 3, 3. Then let's calculate remain for 5. 3 minus 5 is minus 2. So we found negative. So we'll exit. Then for 5. For 5 we have only one choice. We can choose 5. If we choose 5, then let's calculate remain. So 1 minus 5 is minus 4. This is a negative number. So we'll exit. So we're done for the first iteration of this for loop. Now this for loop points to this element 3. Now let's see what's happened then. So first we choose 3. So let's subtract 3 from target. Then we get 5. We have 2 choices for 3. There is 3 and 5. Now let's subtract 3 from 5. Then we get 2. Again here let's subtract 5 from 5. Then we get 0. Here we can have again 2 choices, 3 and 5. Let's calculate remain for 3. That is minus 1. So we're going to exit from the current recursive function call. Then let's calculate remain for 5. We see minus 3. Same thing here. We're going to return. Then we have here 5, right? And we see remain equals to 0. That means we found a combinations that add up to 8. So 3 plus 5 equals to 8. So let's add this to our answer list. So at this part we get this list. So we're done for the second iteration of this for loop. Then this loop will point to the element 5. Okay, let's see what's happened when it points to 5. For 5 we have just only one choice, that is 5. Okay, so first let's calculate remain. So 8 minus 5 is 3. Let's choose here 5. This is our only one choice. If we subtract 5 from 3, then we get minus 2. So we're going to return. So we're done with this for loop. So at the end, we get our list equals to this list. And this is our answer. And this is how we can solve this problem. This code work in DFS manner. That means depth first search. So first, it will traverse this 2, then it goes to this 3, then 5, then 3, from here 3, then 5, then 5, then here 3, then 3, then 5, then here 5, then 5. Okay, this is how depth first search works, and this code works in depth first manner. Also for this, first it traverses, then this, then this. Okay, so it works like this. First this, then this one, then this one. Alright guys, this is how we can solve this problem. For space and time complexity analysis, check the source code. We have the time and space complexity analysis in the source code. Alright guys, hope this concept was clear. We have concrete implementation in Java is attached to this video. Check that out. We have explained everything that we need to understand this problem. If you have any question, if you have any suggestion, let us know. Thanks for watching this video. I will see you in the next video. Till then, take care.